As we saw in the previous lectures, the evaporation of sweat is the major mechanism for losing heat during exercise. And this has physiological consequences because the body loses fluids. If we look at how sweating-induced dehydration affects the body fluid spaces, we can see in this slide that progressive dehydration by combination of exercise and the heat to approximately 2%, 4% and 6% of loss of body mass was associated with significant decreases in the intracellular fluid volumes and also the interstitial fluid volumes. There was an early decrease in the plasma volume, but you can see that it's reasonably well maintained, at least in this study. Other studies have suggested a progressive slight reduction in plasma volume over time with sweating-induced dehydration. The loss of these body fluids does impact on performance. In this study, subjects exercised for an hour at about 75% of their VO2 max and then performed a time trial to exhaustion at about 90%. So it's sort of like the sprint to the finish at the end of an endurance event. And you can see that when subjects were dehydrated, there was no fluid replaced during the exercise, their exercise performance was reduced. There are a number of changes that occur in various physiological parameters when you exercise for a reasonable period in the absence of fluid ingestion. In this study, trained cyclists exercised at about 22 degrees, so not particularly hot, but a significant metabolic heat production. And on one occasion, they exercised with no fluid replacement, and on the other, they ingested fluids at a rate which minimised the loss of body mass. You can see that when fluid was not replaced, there was this reduction in blood volume, and that was reduced somewhat when fluids were ingested. You can still see, however, this initial reduction in blood volume, which is related to the increase in hydrostatic pressure with the onset of exercise that tends to promote the loss of fluids from the plasma space initially. And then the longer, slow decline is relating to sweat loss. You can see that with fluid replacement, there was a lower increase in heart rate, and this was associated with a maintenance of the stroke volume during exercise and a maintenance of the cardiac output during exercise with fluid replacement. And as I showed you in the previous lecture, ingesting fluid during exercise can slow the rise in core temperature during prolonged exercise. But again, I'd make the point that most of the increase in core temperature is related to the metabolic heat production during exercise. So in terms of the benefits of fluid ingestion during exercise, and these refer to the parameters relative to the trial where there was no ingestion of fluid, we see an increase in the blood volume, we see a lower heart rate, there's an increase in stroke volume and cardiac output, a lower core temperature, so lower plasma sodium and osmolality. Interestingly, it's been shown that fluid ingestion also reduces muscle glycogen use during exercise compared with a trial where no fluid was ingested. And again, this appears related to both the increase in core temperature and a slightly higher plasma adrenaline level when no fluid is ingested. And as I showed you, increasing fluid ingestion during exercise is associated with enhanced exercise performance. Having said that, one needs to be careful about fluid ingestion, and there are hazards associated with excessive fluid intake. And in recent years, endurance athletes have been shown to demonstrate hyponatremia, or a reduction in the plasma sodium concentration due to an excessive intake of fluid. And this has also been referred to as water intoxication, and that's associated with cerebral and pulmonary edema, and in some cases, death has resulted. So overhydration has significant risks associated with it. In some cases, ingesting too much fluid is associated with gastrointestinal distress. And also, it's been suggested that this adds to the body mass, and particularly if you're in a weight-bearing sport, might impact on your ability to perform. Having said that, in the few studies that have tried to look at the balance between losing body mass and needing to carry that lighter body mass versus the negative effects associated with the loss of body fluids, it suggests that there is some benefit in drinking during exercise. However, fluid intake during exercise should never exceed the fluid losses. In many sports, it's very difficult to do that because of the lack of access to fluids. Where sports and where athletes are provided with ready access to fluid, they should never ingest more than they lose during exercise. And there's been some question and some debate as to whether athletes should simply rely on their thirst and whether thirst is an appropriate measure. And one could argue that the thirst mechanism is a physiological adaptation to ensure that there's appropriate fluid replacement. That said, if athletes drink ad libitum according to their thirst during exercise, they generally become somewhat dehydrated. Interestingly, their plasma sodium stays at about resting levels. So there'll be ongoing discussion about what is the true measure of fluid replacement and how it can be optimised performance. In reality, most athletes are unable to fully replace their sweat losses during exercise, and some attempt to do so is associated with improvements in performance. During recovery from exercise, an important physiological response is to increase both the reabsorption of sodium and the reabsorption of water. And there are hormones which are important in doing this. There's activation of the renin-angiotensin system and increases in aldosterone, as well as increased levels of antidiuretic hormone. Aldosterone will facilitate sodium reabsorption in the kidney, and together with antidiuretic hormone, that will contribute to an increase in fluid reabsorption from the kidney. Aldosterone can also act on the sweat gland, and it's thought that the lower sodium in the sweat after a period of acclimatization is a function of the increased exposure or the increases in aldosterone following each exercise and heat exposure. In terms of recovery after exercise, water balance and sodium balance are very closely linked. And here is an acute study looking at the restoration of water balance with different beverages containing different amounts of sodium. And you can see that the higher sodium intake was associated with a more rapid restoration of the sodium balance and therefore a more rapid restoration of water balance. And so many of the oral rehydration solutions, including sports drinks, contain electrolytes to improve the retention of fluids that are ingested after exercise or after periods of dehydration, for example, during sickness or dehydration induced by cholera or other blood-borne diseases that induce vomiting or diarrhea and rapid fluid loss. For athletes who have longer to recover, the ingestion of a meal usually contains more than enough sodium to facilitate the restoration of sodium balance and water balance. However, if rapid rehydration is required, then the inclusion of electrolytes in a rehydration beverage can facilitate that process. And finally, recovery is really the preparation for the next bout. And if there's suboptimal restoration of the body fluids, that can have a negative impact on subsequent performance. Here's a study in well-trained runners looking at the impact of dehydration on 1500 metre, 5 kilometre and 10 kilometre running performance. This was done using a diuretic to increase the fluid loss from the body. And you can see that a relatively small reduction in body fluids was associated with significant reductions in exercise performance. There are some sports that are weight regulated, and athletes, if they're struggling to make weight, will often resort to dehydration at the last moment to try and make weight. And that needs to be monitored and even discouraged because of the potential impact, certainly on exercise performance and even on health. So ensuring adequate hydration prior to exercise is also an important strategy to ensure the optimum performance.